Hello, this is Pat Kelly. Okay, in this problem, they ask us to just complete the table. As you can see, what's going on is we're trying to use some real-world examples of our exponentials that we've been learning. And in this case, the interest that you earn at a bank. Okay, so they're telling us here that we put a principal in of $1,000. The bank's offering us a rate of 3.5%, and I'm going to keep it in the bank for 10 years. And we're going to fill in this table according to the different periods at which the bank might compound that interest, just once a year, twice a year, 4 times a year, etc. In particular, I'd probably ask you to pay attention to the P, the R, and the T in terms of the work that I do for this problem, because those are the players that are going to change when you're going to do your own problem in the next few exercises. Okay, so see how they interplay in the formula, which is actually the right place to start, is the formula that we need. If you know this, that's good. It depends if your teacher is going to make you memorize it, or maybe they'll be nice and give it to you. But it all comes down to our formula of A equals P parentheses 1 plus R divided by N raised to the N times T power. Okay, it's mostly just plug and chug. Grab your calculator. Before I get rolling though, I'm just going to take one real quick step to make this R more calculator friendly. Let's just write it as a decimal. So R equals 0.035. Okay, and then to fill in the table, it really is just making sure you put the right number in the right place in this formula and then grind it through a calculator. Okay, so for the first N value of 1, I'm just going to go right to the formula. A equals my P of 1,000, 1 plus my R value, 0.035, divide by that N, which is still just 1 for us. And I'll do a little bit of math in my head on most of these exponents. Is N times T, N is 1, my T is 10 years. So 1 times 10. Okay, that's really calculator fodder at this point. If you want to grab your calculator, I'll grab mine. And I'm just going to plug in 1,000 times, I think I can do the math in my head on this one, but if that sounds like a joke, later on you might actually do the computation for some of these different values of N. But this is just 1 plus 0.035, so 1.035. I'll raise that to the 10th power. And I am getting approximately, because I'll have to round here, 1,410. 2 decimal places make sense if it's dollars and cents, so this is going to go to 60 cents. All right, that's our first answer to fill in this table. I'm going to put a 1410.60. Okay? All right, got the ball rolling. Now we move on. Just change our N value of 2. So our next N value of 2, just going to my formula, A equals, same P value for this problem, parentheses, 1 plus 0.035 divided by that N value of 2. Close parentheses, N times T, and I'm still doing a little bit of math in my head, 2 times the 10, so 20. Grab the calculator, 1,000 times 1 plus 0.035 divided by 2, raised to the 20. My result is 1,414.78 cents if I'm rounding. I'll fill that in the table. And move on to the next N value of 4. N equals 4. Keeping an eye on my formula the whole time. P is still 1,000. 1 plus 0.035 The only thing that's changing here is my n value is now 4, divided by 4, raised to the n times t, so 4 times 10, 40th power. And then I resort to the calculator again. 1,000 times parentheses 1 plus 0.035 divided by 4, raised to the 40th power. My result after rounding is 1416.91. To the table, I'll just put that entry in. Okay, keep the momentum going. We have 3 of our n values, 3 more to go. Next for me will be n equals 12. And I just keep going back to that formula. A equals, my p is still 1,000, 1 plus, my rate is still 0.035. What's different is my n value of 12. I divide by 12 here. And the exponent is 12 times that 10. I think I can still do that in my head, 120. Okay, plug and chug on the calculator. 1,000 times parentheses 1 plus 0.035 divided by 12, close parentheses, raised to the 120th power. Still dollars and cents, so I'm rounding to 2 decimal place. I get 1,418.34 cents. Back to the table, 1,418.34 cents. Okay, next my n is 365. N equals 365. And real shocker here, back to the formula. Okay, so A equals 1,000. 1 plus 0.035 divided by raised to the n of 365 times t. I still think I can do that in my head. 3650. And then to the calculator, 1,000 times parentheses 1 plus 0.035 divided by 365, close parentheses, raised to the 3650 power. Rounded to 2 decimal places, I'm looking at 1,419.04 cents. Up to the table, 1,419.04 cents. And of course, what you're seeing is, as we're filling in these entries, you're getting a little bit more money depending on how frequently the bank compounds their interest. So if they did it monthly, you'd get this $1,418.34 at the end of the 10 years. If they compound it daily, you'd get an extra 70 cents over 10 years. But every penny counts. Last entry is when we, or the bank compounds continuously, right? It's not going to happen in the real world, but mathematicians love this concept. What that does is it actually tweaks our formula just a little bit. So let me come over here, and when we have interest compounded continuously, my A equals the principal times E raised to the RT. Okay. What we're talking about doing is compounding that interest every instant, every second, instantaneously. And we have a limit for that, as that's done infinitely many times over the 10 years. That limit goes to E. That's why the mathematicians like it so much. For us, what it really means is you just have a simpler formula to follow. So I'm going to go to my last entry, and I don't really have an n value here. Again, it's every split second that you can think of is when you're getting your interest. I just have a new formula. A equals, my P is still 1,000. My base is E, and I raise to the R 0.035 times T, which is 10, power. So 1,000 times E raised to this, let me actually do a little bit more math in my head. I think I can. 1,000 E raised to the 0.35 power if I multiply by 10. I'll still let the calculator do the hard part though. If I grab the calculator now, 1,000 times E raised to the 0.35 power approximately equals, if I round, 1,419.7 cents. Just to finish off the problem, let's go to the table here. 1,419.7 cents. All right. Quite a bit of work maybe, but I hope you see it's all very formula driven. Okay, make sure you know what pieces of the puzzle to plug in the right place. You should be all set. Okay, go try some on your own.